if you're player 8 and you want to win, you can win the first point, and then 3, where you get 1, and then 3 more points, each of which counts for 2. And by winning only 4 actual volleys, you would end up winning the match. So here is an example of the way the game will play out. Let me try just to talk to it for a minute, just to make sure everybody understands. On the left is sort of the numbers of the players in order that they're waiting. At the beginning, see that on the top row, it says numbers 3, 4, 5, 6, 7, 8. Those are the players waiting in line, right? On the right, it says, keeps track of how many points each player has. And after the first point, if 1 beat 2, 1 would have 1 point. Then if we looked at the cue on the left on the second row, 1 is going to be playing 3. 2, if you look at it, is now at the end of the line. If 1 beat 3, 1 now has 2 points as we move down that. Then 1 beat 4, 1 has 3 points. You can see that the game plays out at that line in the middle when 8 first plays. Note that when 8 beats 7, 8 gets credit for goes from having 1 point above the line to 3 points below it. That's because every point played below the line counts for 2. And finally, at the end of it, if you look at it on the right, player number 5, it turns out to be the one that's the first to get 7 points. And so player 5 is the winner. Any questions about how the game is played? So it's kind of a little bit complicated, but actually quite fun to watch. I found it was fun to think about because you'd be rooting for a player you bet on, and you'd realize that, oh, my player will win if the next player loses, the other guy I don't care about, and then my player goes and gets 3 points in a row, then I'll win. So you can think ahead to see how your player would win. Now, there are various other complicated rules I don't want to go into to decide how you break ties. So the game ends when the first player gets 7, but they also want to keep track of who comes in second and who comes in third. And there's a complicated set of rules of who plays who to determine that. So what was interesting about it? We said that there was some advantage everybody felt to being at the first one in line. How can we figure out exactly how much advantage there is to being first in line or not? And to do that, we used a computer technique, a computer simulation technique called Monte Carlo simulation. How many people have ever heard of Monte Carlo, the city? What do they do in Monte Carlo? Gamble, exactly right. So Monte Carlo simulation is a technique based on randomness, using randomness like dice flipping or coin flipping to measure things and understand things. So an example of this idea is in what they call Monte Carlo integration. Suppose you had that painting and you wanted to figure out what the area of the painting is, how much space it would take up on your wall. How would you figure out the area of the entire painting? I think that's a pretty easy job, right? You could measure the length of the painting, you could measure the width of the painting, and you could multiply it together. Does everybody agree with that? Now, how would you find the area of the red spot, though? If I now want to ask you how much area is that red spot on the wall, that would be a lot harder to tell, right? Well, what if you had a machine gun? It would then be relatively easy to tell. Why? You go into the audience, clear everybody away so nobody gets hurt, close your eyes, and shoot at the wall randomly. And then what happens? You've got bullet holes in the wall. The number of bullet holes in the red part should be approximately equal to the fraction of the bullet holes that hit the red part should be proportional to the area of the red over the area of the entire painting. Does everybody agree that if half the area was red, about half the bullets should hit the red part? Does everybody agree? So that's a way that you can use random numbers to kind of answer questions about the world. Okay, and that's the idea of Monte Carlo analysis. Any questions? So what did we do? We didn't use a machine gun. What we did instead was we wrote a computer simulation to pick a random number from using a computer. And what we did was play a highlight game in the computer where we would pick a random number to decide whether the first player or the second player won the point. Then if the computer decided the first player won the point, it would then have the second player play the third player. And again, pick a random number to decide whether or not which player won that point. And by using random numbers to simulate each individual point that was played, we could figure out who would have won a simulated game. And if we played then 1 million of these simulated games, we would figure out the player that won, that had the advantage because they started in a good spot in the scoring system. We would be able to measure that advantage because over the course of 1 million games, they should win more times than everybody else, even if we flip the coins equally. Do people get that idea? Okay, any questions about that? Okay, so the neat thing is we're going to play each game 1 million times. We're going to play 1 million holiday games in our computer by flipping a coin to decide who wins each point. And just like the random bullets gave us an idea of the area, the results of these random games will give us an idea of who's going to win which position in the scoring system is the most likely to win and therefore the best to bet on. So what happens if we do this? Again, we can figure out who has the advantage. If all players are equally likely, meaning equally skilled, meaning that whenever they played it was a fair coin flip, 50-50, we would still find that player 1 and player 2, which are the same, would basically win 16% of the time. Player 7 was the unlucky one. Player 7 would win only a little more than half as often because player 7 couldn't quite take advantage of the doubling the way player 8 could. And there were similar effects to figure out what's the likelihood someone could finish second. That's what I mean by place. Or third. That's the likelihood that someone would come in third. And so you see that player 1 and 2 have the advantage in pretty much all of the possibilities. So it's much better to be player 1 or player 2 than player 7. Any questions? So knowing this would probably help you bet, because in fact, that's really what happens. When we did this, we looked at some highlight statistics and saw what was the probability that each position won over 4 years' worth of highlight matches. And we found that, again, the most likely player to win was 1 or 2, and the least likely to win was player 7, which is exactly what we would expect from our simulation. Now, the bias here is not as strong because if you look at it, it's not as advantageous. The player 1 and 2 don't win as often as we thought, and player 7 doesn't lose as often as we thought.